Hello, we're Team 14. My name is Alex Galuzian. This is Xiaohua, Edgy, and Nathan. And today we're going to talk to you about our model to predict house prices in Mandeville, Louisiana.
So our first step in creating a model was to gather some sample data. And to do this, we went to Realtor.com and we looked up single-family homes in Mandeville. After that, we used a program to randomly select homes from each row of the results. In total, we collected 66 data points, which we then put each of the home addresses into lat long to figure out the latitude and longitude of each data point. So from this data, we estimated that the best variables to predict the home prices would be the number of bedrooms, the number of bathrooms, the square footage, the latitude and longitude, and finally, as a categorical variable, whether or not the home was renovated in the description or not. After that, we created a map with the prices of the homes by inputting the latitude and longitude as the y and x axes and overlaying a map on top of that. We also made a map of whether or not the homes were renovated. As you can see, there's a lot more homes that were not renovated than were. And finally, we made a map on how many bedrooms there were per home. And then, yeah.
So next we decided to make a multiple regression model. This would allow us to determine which variables to keep in our model in order to predict price. In order to do that, we formed a test set and a training set. The test set only contained 20% of our data. So in order to make the test set, we randomly put our data into Excel, and then we selected randomly the middle 13 of the data from Excel. So first, using jump, we used the stepwise function, and we created the backwards elimination model. This model used bed and square feet to predict price, and you can see the R squared adjusted value is 0.813, and that means that 81.3% of the variability in price is accounted for by bed and square feet. Next, we made the forward elimination model. You can see that the R squared adjusted value is a little bit higher, 0.816, which means, at least initially, that it's a better model at predicting price. And this model included longitude additionally, which we thought was odd at first, so we decided to make a scatter plot of longitude and price, and you can see that as the longitude increases, the price decreases, which means that there's a linear relationship here, which makes sense why it would be included in the model. And finally, we just used minimum AICC forward model, which ended up making the same model as for the backwards elimination using bed and square feet, the same R squared adjusted value. Next, we performed cross-validation. So in order to do that, we took the models that we created from the training set, and then we used the test set in order to see what the R squared adjusted value was. And what we're looking for here is whether there's a serious or drastic decrease in the R squared adjusted value. And you can see for all of our models, the R squared adjusted value, it actually increased by about 0.05, which is acceptable for all of the models. So the best model then we determined is the training set forward model, which has the highest R squared adjusted value, 0.816. And you can see this is our final model. This is the equation here. If you know the longitude, bed, and square foot of a home, you're able to predict the price of the home.
So we checked for the assumptions to make sure that the housing predicting housing prices in Mandeville, Louisiana is more accurate. So first we checked for the constant variability assumption, which is not met because we can see a fan shape from the picture. Although there are a few outliers, the linearity is met. The independence is met because the data was randomly selected. And the nearly normal condition is not met because there is an S shape rather than linear shape in a normal quantile plot. We also try to use log price, which gives us a better outcome, but we moved forward with our original price.
I think it's important for us to note some limitations to this model. Number one, the forward model constant variability assumption was not met without using the log of the price. This ends up with a less accurate formula for higher priced homes. Secondly, the only sample we used was from Realtor.com. We didn't use any other resources such as Zillow or Trulia. Thirdly, we used longitude, so the model will only be valid in limited geographical areas. Another thing worth noting is the prices for the houses were a combination of listed, sold, and pending status on Realtor.com, and the nearly normal condition was not met with the original. In conclusion, we think that the best model for predicting house prices in Mandeville, Louisiana is to use cross-validation training set forward method, using longitude, square footage, and number of bedrooms as the variables to determine the price. We believe this is the best model due to the high R-squared value and the relatively low number of predictor values. Thank you very much.